Okay, so you're all familiar with plotting points on X and Y, right? It's called the Cartesian coordinate system. When you have a grid with X and Y points. So now there's another one called polar coordinates, which is basically using a radius and angle to plot a point. So it's still two-dimensional. It's just that we're plotting a little bit differently. So let me give you the explanation real quick. It's not too difficult. Green. Oops. When graphing polar coordinates, so we're going to use r comma theta. That's the difference instead of x comma y. First, what I recommend is find theta on your unit circle. Then, once you find it, then move out from the origin towards theta, a distance of r. Does that make sense? Trying to word this good here. Distance r. So basically what I'm saying is you find the angle, and then if the radius is 2, you move out 2. That's it.
What is that saying? Move out from the what?
From the origin, the center.
Okay, thank you.
So here, I think the easiest way is to draw a picture. So given the polar coordinate 2 comma pi over 4, what we're going to do is graph it. So part A is graph. Okay. So let's draw a little grid here. Okay. So pi over 4, we know is 45 degrees, right? So we know it's right in the center. So it's out here somewhere, because theta would be pi over 4, right? So the radius 2 means I go out 2 units. So I'll go out 1, 2. So this is the location of the point. Does that make sense on how you plot these? So you find the angle first, which is pi fourths, then go out radius 2. So that's r comma theta. Excuse me. Is there any questions on this part so far? All right, so I'm sorry, you can go ahead.
That's good.
Okay. All right, so what is another equivalent point for 2 comma pi fourths. Because we know that the unit circle keeps going around and around, right? So I should be able to get there with a different angle. What do you guys think?
Finding the reference angle.
So what point would you suggest to land here again? Instead of 2 pi fourths, what is another way that I can land there?
Like 5 pi over 4?
Yeah, 5 pi over 4 would get me on this side, right? But
2
then-
negative something over 4.
Yeah, yeah. So
Be -7 pi over 4.
I think it's close. So I think putting all your answers together, it's correct. Yeah. So basically, the -2 that we need if we go all the way to 5 pi fourths. So that's the answer, but it's hard to visualize. So let's draw the idea, right? So basically, we would come out all the way to this angle here, which would be a theta of 5 pi fourths, right? But then we go, but remember, we're not actually here. We're in the center. So when we use a radius of -2 to go opposite direction, so I'd end up going over here. So 1, 2. So that'd be the same location. Does that make sense? There's more than one answer, by the way. There's not just one, right? There's more than one way to get there. Okay. Let's do another one, just a quick one here, just in case we are still not seeing it here. So plot, well, let's say 3 comma -3 comma pi 6. In degrees, what is pi 6?
Jack, can you erase the paper, please?
Mm-hmm.
30 degrees.
Yeah, it's 30 degrees, right? So find the angle first to get a reference of what's going on. So I'm about down here somewhere. Then we'll go -3, so that means it'd be over here, right? So the point would be 1, 2, 3. So somewhere over here. Does the main idea make sense? Okay, let's move on to something more difficult. If this makes sense. So the questions will start in the homework something like this. They'll give you some pretty numbers and they'll give you ugly numbers, but eventually they'll move on to something else, which is the converting an equation from polar to Cartesian, also called rectangular. Sorry. Rectangular coordinates or Cartesian means the same thing. So if you see that in the book or the notes, that means X and Y plots. Okay. Polar is just r theta. Okay, so let me give you some formulas you're going to need for converting formulas and equations. So X is equal to r cosine theta. Y is equal to r sine theta. R squared is equal to x squared plus y squared. So these are my formulas here. We also have tangent of theta equal to x over y. You give you everything, oops, sorry, y over x. They give you everything that I think you'll need for this homework. Y over x. If x is not equal to 0. Also, theta is equal to, I guess I should put that in a separate line here. Just not confusing. All right, so theta is equal to pi over 2 if x is equal to 0. That's just a side note there. So there's my formulas I'm going to need for the next few examples. Okay. All right. The polar coordinate of a point are coordinates actually, yeah, are 11, comma, yeah, 2 pi over 3. Sorry, forgot the question. Find the rectangular coordinates. So basically, we're going to use the formulas above to get back to x and y. Because right now it's r theta. Okay. So let's write down everything we know. We know that r is equal to 11. We know that theta is 2 pi thirds, right? Okay, so we're going to use the formula to find the rectangular coordinates for x and y. So then we need to change this guy. The question is asking basically, let me make a note here. Just put it simply, change into some x and y, right? Okay. So x is equal to r cosine theta, which would be equal to 11 cosine of 2 pi thirds. So what the heck is cosine of 2 pi thirds? Let's pull out our circle. Okay. Here is my circle. 2 pi thirds is right here, right? Cosine is negative half. So right here we have 11 times negative half, right? The x value. Okay. So now the y is equal to r sine theta, which is equal to 11 sine of 2 pi thirds. Which will be 11 times square root 3 over 2 that we saw a minute ago. So my answer will be negative 11 over 2, comma, 11 square root 3 over 2, right? This is my rectangular coordinate from polar. Is there any questions as to what we did? Okay. So we converted coordinates from one system to another. That's all we did. Let's do another one. Example 4. Put it in plain English this time. Convert polar to rectangular. So we do the same thing. So here is the polar. Okay, so use the formula. X is equal to r cosine theta. So that would be equal to -4 times cosine of 3 pi fourths, right? Then the y will be the same deal, r sine theta, which will equal -4 times sine of the same angle, 3 pi over 4. Okay. So let's check our circle. 3 pi over 4. Those are both square root 2 over 2. So my answer will be -4 times negative square root 2 over 2. This one will be -4 times square root 2 over 2. So my answer will be, oops, smeared it. Multiply this out, that'll be 2 root 2 comma -2 root 2. So our x and y. Trying to get that glare out of the way. Any questions on it's the same as number 3, just I try to shorten it up a little bit. All right, let's go the other direction, where they give you x and y and they want to know polar. So sometimes a little bit more involved, so let's do that one. I skipped a fraction step here. You see how these reduced? 2 went into 4. 2. 4 divided by 2 is 2. Negative, negative, positive, negative, positive, negative. Okay. You guys have no questions on 4 then? So this time let's convert from rectangular to, oh, I'm sorry. Yeah, to polar. That's right. So here's the point they give us, 7 comma 7 root 3. So I need to get to my r theta. Well, we know that, and of course this is x and y, so I'm going to make a note there. All right, so we know the formula for r squared, right? R squared is equal to x squared plus y squared, which means that r is equal to the square root of x squared plus y squared, right? We'll just plug in the x and y that were given. So r would be equal to 7 squared plus 7 squared times square root 3 squared. And if you square both this entire thing, you're going to square each piece, right? So that'll give us square root of 49 plus 49 times 3. Which would be what? Yeah, 14, right? So r is 14. Double check me though. Okay. So we got r. That's cool. So now we need theta. So earlier we said that theta is equal to tangent. Well, actually, we said, let me double check the formulas I gave you. So tan theta is equal to y over x. So we can make another formula ourselves by solving for theta. So tangent of theta is equal to y over x. So if I solve for theta by doing tangent inverse of both sides, right, like we did back a couple chapters ago, we can solve for theta. So theta is equal to tangent inverse of y over x. Because we need theta. So plug it in. Theta would be equal to tangent inverse of 7 root 3 over 7. So theta would be tangent inverse of root 3. I believe the calculator is going to give us like 60 degrees. Let me double check though. Yeah. So we got the angle. So conversion from rectangular to polar. We need to find the theta using this formula here. And we use the r formula to find radius. Is there any questions on those steps? So r is 14. Theta is pi over 3. So you'll have so the first few questions will be going from polar to rectangular, and then rectangular to polar, and then eventually you get to let's see here. Equations. An x and y equation to an r theta equation. Those are the little bit more challenging questions. So the variables x and y represent rectangular coordinates. Write the equation using polar coordinates. Which means r theta. Okay. So here's the first example. 2x squared plus 2y squared equals 8. So it changes into polar. So we're going to need all the formulas for these types of problems. So I would recommend having them handy. Like, for example, r squared is equal to x squared plus y squared. X equals r cosine, right? Y equals r sine. Although I can kind of already tell that x squared plus y squared is already in the question, right? So if I divide everything by 2 on both sides, everything by 2. That give me x squared plus y squared equal to 4. So we know that r squared is equal to x squared plus y squared, so we'll replace it. So now we're pretty much in polar. That wasn't too bad. Solve for r by square rooting both sides. R gives me 2. So there's no theta, right? Notice that? Do you remember when we would graph equations of lines? Sometimes there was no x or no y. It would give you a specific kind of graph. Let me give you a picture. Okay, so for example, y equal to 2 has no x. So it gives you a horizontal line. What it means is that x can be anything, but y will always be 2. See how the axis varies along the whole path? But it's horizontal, meaning the only y value that I hit is 2 all the time. So x equal to 2 does the opposite. X is always 2, but y is every single number. That's what creates the vertical line. Do you remember this? back in, I remember thinking before college algebra. So if there is no theta, basically your radius is 2 for all angles. See if it does it on here. Meaning, right, here's my circle. I'm seeing to grab a point. Oops. Anyway, so R is 2 for all theta, meaning theta will create a circle because I'm going to be going hitting every single angle, right? Where R is always 2, therefore I create a circle. So that's what this means. If theta is equal to, let's say, 45 degrees, see if it does it. Nope, won't do it for me, will you? Maybe I can switch to polar. There we go. Polar. Delete my lines here. This is a polar graph, by the way. I think it's a little easier to see. Like that first example we did pi over 4, and we went out 2. So this is what it looks like. So you'd go to pi 6 or whatever, and you'd go out 1 radius, 2 radius. So that'd be your point. That's what I was trying to draw at the very beginning. You'd have a point here. But anyway, if you have, I can't seem to graph this guy, but if you were to see this example on your homework, this means that the radius can be anything, but the angle is always pi over 4. So that would mean that pi over 4 is right here. So the line would simply be this. Let's just have to draw it in Cartesian. It'll look like this, the blue one. So if theta is pi over 4, r is every single number, meaning it goes forever in both directions. So this is a line, this is a circle. When we're talking about polar. Okay. So that's what this looks like. This is a circle. Theta is all real numbers, all angles.
So that would be the answer for that, is just R equals 2?
I mean, yeah, I think so.
Okay, cool.
Unless they ask you to graph it. But no, yeah, that's it. Okay. I think in the notes I sent you, they have some pictures. Let me open that up. Okay. Trying to help you get a grasp here. So yeah, here's pi over 4 and then -2 and go down 2. So we were talking about the beginning. The one I wanted to show you though. Where is it? Maybe they're not on this picture. Lame. Might be the next section. Anyway, but you get what I'm saying though, right? You see why it would be a straight line? Theta when it's just theta? Or no? Okay. Here we go. Yeah. That's what we're going to see in 10.2. So we'll wait then. Let's do a couple more conversions. We'll save it for 10.2. Example 7. Convert to a polar equation. So now we're going the other direction. They're giving us x squared equal to 13y. So I'm probably going to need these guys here. Okay. All right, so we have an x squared and we have a y, so we can plug in these values here. So this would simply be r cosine theta squared equal to 13 times r sine theta. So that would be r squared cosine squared theta equal to 13r sine theta. Now I'm going to subtract this over. This would be r squared cosine squared theta minus 13r sine equal to 0. So this has been converted completely to polar. I have no more x's and y's. I just have r and theta. So this is pretty much it. Is there any questions on what we did?
So that one's been solved with that line at the bottom.
Yeah, it's been converted to polar. Let's do a harder one. Convert to a polar equation. (15xy) equals to 1. So on these, you can sometimes simplify a little further, even though this is correct. Sometimes there's more you can do because we have all those identities that we've learned. But let's see what happens here. It looks like I might be able to use one. This would be r cosine for the x, r sine for the y, right? Multiply that together, and that gives us 15 r squared times cosine theta sine theta. I went ahead and multiplied these r's. Okay. Now I see an identity that we can probably apply. I don't know if you remember that sine 2 theta is equal to 2 sine cosine of theta, right? The double angle formula for sine. So I have the sine cosine right here, right? I do not have a 2. So I can multiply by 2 on purpose just to simplify it. So I can multiply both sides by 2. I put the sine first just because, not because it matters. So that 2, I'm going to put right in front because that's what's going to be converted. So this right here will become sine 2 theta. Rearrange terms. Okay, so substitute it. Now we got 15r squared sine 2 theta equal to 2. I don't think we can go much further. You could set it equal to 1, I guess, divided by 2, but I think that's fine. Now, technically, this answer up here was not incorrect. I just used identities to make it more compact. If the homework tells you to go a little further, then maybe you'll have to, but technically this is fine.
Why doesn't the 2 affect the 15 at all?
It can, if you want it to. I just chose not to. Because I was going to use it as part of the substitution, right?
Okay.
So yeah, I was saving. I introduced the 2, but didn't multiply the 15 to get 30. I moved it over here to replace this with sine 2 theta.
Okay.
So I have a question. I'm sorry, maybe I missed it. How did you get over sine 2 theta?
No, this is just what I'm substituting. It's not a fraction.
Oh,
More of a circle, I guess. It's a note.
so that's saying like 2 sine theta cosine theta equals sine 2 theta?
Right, that's what we're using right here.
Oh, so that's not a fraction, so,
No, I'm sorry, was that confusing? I was just trying to say that this is being replaced.
You good?
Yeah, let me erase it. Is that better?
yeah.
I just got a little behind.
No, it's okay. I'll just put an arrow instead. You guys have any other questions on this problem? Okay, let's see here. No, that's all for 10.1. Any of the problems at the beginning that were confusing or anything we talked about today?
I did have a question on one of the other problems.
Okay.
So
Which one was it? Do you remember?
on example 5,
Okay.
I don't see how you got that theta equals pi over 3. So from on the right-hand side, on the
Here.
bottom, yes, you say theta equals tan inverse, right, square root 3 equals pi over 3. I didn't catch where we got.
Okay. It has to be with a calculator. I didn't show that. So you plug in the square root of 3, which gives you 60 degrees, which is pi thirds.
Oh,
That's the only way to get it. Either that or remember the unit circle, but
oh, wait, because I did it and I got like a weird 1.047.
yeah, yours is in radians. That's the only difference. I believe this is the same. Let me see. Pi. Where the hell is it? You got 1.04719.
Mm-hmm.
Yeah, see how it's the same as pi thirds?
Okay, so I was supposed to be in degree.
Yeah, I like leaving it in degrees because I can tell right away, at least in my memory. It's like, okay, I know what 60 is. That's pi thirds. But if I look
Oh.
at this, I'm like, I don't know what the heck that number is, right? So it's up to you, though. I recommend degrees for your calculator.
So when I go to 60 degrees, okay, I see it now.
You see what I
Thank-
mean?
Yeah, so it's just that my calculator is just in the wrong mode.
Yeah, that's all. Okay. Let's see, give me one moment, guys. Okay, so 10.2. Polar equations and graphs. All right, so example 1 is transform the polar equation in rectangular coordinates. And after you do that, you identify the graph. So then identify the graph. Okay. So theta equals 5 pi over 4. So I want to convert this into rectangular. So remember that tangent of theta is equal to y over x, right? So if I take tangent of both sides, I can get a value. And I know that that value would be equal to y over x, right? So let's show them the next step. So tangent of 5 pi force, I believe, is equal to 1 on your unit circle. But I also know that tangent is this guy, right? So y over x is equal to 1. Does that make sense? Then just multiply both sides by x, and you'll solve for y. So y, these x's will cancel. Y is equal to x. So at this point, this is just a 45-degree angle line, right? So this would look like this. So there's the equation and the graph. Just a line graph. Is there any questions on example 1? What we did?
Yes, sorry. So tan theta equals tan 5 pi over 4. Is that just saying like that
Yeah.
is theta, right?
Yeah, I'm doing tangent of both sides here. So tangent of theta, tangent of 5 pi force.
Which is theta. Okay.
Yeah, so the theta's right there. This is 1.
Got it.
Right, example 2. Transform the polar equation to an equation in rectangular coordinates. Then identify the graph. Okay, so I need to convert this. So let's write down our formulas that we're gonna need. I don't think I'll need the sign guide, but there it is. Okay. So I don't have an R on this cosine to change it into an X, but I could introduce it on both sides, right? I could say R times R equals 6 cosine theta times R, which gives me R squared. I'm going to put the R right in front of the cosine because that's what I'm going to replace. Because this right here is X, right? So R squared is also equal to this guy. So that'll give us X squared plus Y squared equal to 6X. Is there any questions up until this point? Okay. So remember, we substituted the R squared with this guy and the R cosine with X. So now I need to identify the graph. It looks like a kind of circle. Maybe, yeah, it's going to be a circle. So we need to get this into standard form. So standard form for circles. Let's see here. Is x minus h squared plus y minus k squared equal to r squared. I feel like we talked about this a long time ago. Has a center at hk.
That's X minus A squared, is that right?
X minus h.
H. Okay.
All right, so I'm going to try to get this into standard form and and find the center of the circle, etc. So we're going to have to complete the square. So get all the x's on one side. By subtraction. Right, I subtract the 6x over here. Now the y squared is good. It's already a perfect square. I just need to deal with the x stuff. So I need to introduce a constant that will complete the square for the x terms. So I need to find that special number that will complete the square. Then I'll need to add it to both sides. So that number is always half of b squared. So half of 6 is 3, and then you square it. So that would be adding 9 to both sides. So now this will factor perfectly like this. Do you guys remember this?
Absolutely not, but I'm following along. So
Okay. So we had to complete the square, sometimes for both the x and the y stuff, in order to find the center of a circle. So since there was only one y squared term, that one was done. But since I had two x terms, I had to complete the square using algebra and then factor this guy into a perfect square. Once I've introduced that special number, that number will always be half of this term, the b term, right? remember the standard form, right, of a quadratic. So half of this term. So to complete the square, leave you a note here. Add 1/2 of b squared to both sides. If you don't have two sides, then you'd add it and subtract it. If it's a weird question, but anyway, once it's in this form, you have the center, right? Center is at 3, 0, because there's no constant on this guy. So it's a circle with radius what? Right, what does the standard form tell you? It's equal to an r squared, right? So this is the radius squared. So if you graph it, it'd be centered at 3, 0 with a radius of 3. So I don't know if I can draw it here or not. 3, 0 would be 1, 2, 3, somewhere out here. Then you'd go out 3 in each direction. So 1, 2, 3, 1, 2, 3. Something like this, but anyway, I can't draw very well. Let me show you the prettier graph on the grapher, the online grapher. Okay, so it'll be x minus 3 squared plus y squared equals to 9. Oh, crap. So there it is. So the center, as we said, it was 3, 0. Right? And we went all the way out 1, sorry. Yeah, 1, 2, 1, 2, 3. 1, 2, 3. So in every direction, we have a radius of 3. So that's why we want it in this form, because once it's in standard form, we know it's a circle for sure. But a good giveaway when I was starting the question, the reason I even knew that was because I saw x squared and y squared, and okay, that's got to be a circle. I just need to get it into that form using algebra. That's what we did here. This is completing the square. Once it's complete, then you can use this formula here to help you get information. You got the center, got the radius. Okay. Technically, this part up to here is the transformation or the conversion from polar to rectangular. This extra stuff was just trying to identify the graph. That's all that was. Okay.
Right, but that was
that?
in the next, that was like, I didn't understand a single thing about this problem. So can we do another example? You know,
Yeah,
I guess where it's just less wordy, maybe?
sure. Well,
I don't know if that makes sense.
Did you understand this part? The
Yes,
beginning part? 'Cause that's the
yes.
main part. This part is old school algebra that is probably fuzzy for a lot of people. Does you guys want to go over the completing the square a little bit more?
Sure.
Yeah, that sounds good.
Okay, let's do that first. So, because this part I think we got because it's the new stuff, right? We're just using a formula. We converted it. So this is like the end step. after that, we're doing something about we're doing circle stuff from a long time ago.
But we
So,
need to do that, right, in order to solve the problem.
yeah, the book assumes you remember all about circles and equations of circles, which
Okay,
is not, might not be true, right?
true.
So let's look it over real quick. Okay. All right. Let me do a circle example. Review of circles. Okay, so first thing we wrote was the standard form that we need this formula here.
I love you.
So then remember the center is at HK and radius is equal to R, right? So if you had an example here, just a little side example. If it's already in standard form, we can find out all kinds of information. Right? That's 48, by the way. What is the center? When it's in standard form, notice how if they're both minus, they just switch signs to positive. So it's always the opposite.
Negative 4, 6.
Yeah. So negative 4, 6 will be the center. Radius, remember how this is equal to R squared, so you'd have to square root this guy. So radius is equal to the square root of 48, which is, does that reduce? What goes into 48? Let's see here. I feel like 16 does, doesn't it? Yeah, it does. This is technically 16 times 3, which reduces to 4 root 3. So this is my radius. This is my center. So if you were to graph this guy, it would go out this much distance, and it would be centered here. So that's what all this information tells you. Okay. Let me graph it for you. Equals 48. Okay. Now, so here's my circle. And we said the center should be negative 4, 6, right? So there it is, right at the center. And we went out a distance of square root of 48. So in decimals, I don't know what that is. Let me see. That's about 6.9, so almost 7. So from here to the edge of the circle, it's 7. So we got all this info by having the circle in standard form. Okay. Now, it's not going to be given to you in standard form very often. So we got to get used to completing the square. So let's practice that guy here. Okay. So here is a circle that we can't get any information from because the square is not, the square hasn't been completed yet. So I'm gonna have to complete the square twice, one for the y, one for the x part. So this will give us some good practice. So the way you should do this is group all the x's together, move the constant to the other side, group the y's together, and go from there. So x squared plus 18x. I'm going to group those guys together. Parentheses are doing nothing. I'm just putting them there. Y squared plus 14y go together. And remove the 105 over here by subtraction. Okay. You guys still with me?
Yes.
All right, so now to complete the square for the x, meaning it needs to factor perfectly into a perfect square. That's what I mean by completing the square. Is when I'm done, it'll factor like this. And when I'm done with the y, it'll factor like that. It will no longer be a bunch of terms. So that's what we're trying to do. Because when it's in this form, as you can see, we know the center, we know the radius by just looking at it, right? So let's do it. So the procedure, I recommend leaving a little blank spot here for the number that we're going to add. And then the same for the y. Now that special number will have to be added to both sides. So one for the x, one for the y. So this number, we said has to be half of the b squared. So the b term is the 18. So what is half of 18?
9.
And if we square 9, what do we get?
81.
So that's the number that's going to complete the square. So now this is going to factor perfectly in just a moment because we completed the square. Now let's do it again. What is half of 14? Because that's the b term.
7.
And if we square it,
49.
we got it, right? So then we're going to add that to the other side to keep the balance. So plus 81 plus 49. Oops, it looks ugly. All right, so when you try to factor this, it's going to factor into a perfect square. X plus 9 squared. This will factor into y plus 7 squared. Add up all this garbage, you should get what, 25. So now it's a standard circle equation. Okay, so factor this using trial and error. You should get this guy and this one. So now now we can answer the question, right? What is the center? What is the radius?
-9, -7.
Yeah, -9, -7. Radius will be the square root of this guy. 5. So we were doing this procedure on that last question. We're doing it quickly because the book was assuming that we remembered, but I think it's good to review just in case. Does this help a little bit?
Yes, it does. But sometimes when I'm writing, I can't listen all the time. Can
That's
you
okay.
just go over the 2 lines before the center, how you got that 81, like x squared plus 18x plus 81?
Where the 81 came from?
Yes, if you could just go over that again, because I know you
Yeah.
were saying something about square this or.
Yeah, so this special number that completes the square comes from taking this number here, the coefficient of the x, You cut it in half, which is 9, and you square it, which is
Ah.
81.
Okay, cut it, okay, that's what I missed, the cut in half, okay.
And 14, you cut it in half, which is 7. Square it, 49. So it will always be this way.
Okay, that helps, thank you.
So on the last question, let's go look at it real quick. We'll come back to that. Maybe it'll make a little more sense now. So we converted it, right? And we got to here. We're like, oh crap, there's an x squared and a y squared and a 6x. Like, so we need to convert this into a standard circle equation. So that's what we did here. When we get this form. So it's the same thing. And once you have that, we can have the center, we have the radius, and you can graph it. Okay. Have any questions on this example here? Excuse me. Okay, well, let's do another one, like the last example where we all got a little confused. So we'll do the same thing, and then we'll do a transformation to that standard circle equation. So same thing as number 2, transform the polar equation to an equation in rectangular coordinates. Then identify and graph. Okay. So the reason we changed it into that general circle is because they asked us to graph it. Okay. So r is equal to -2 sine theta. So I'll write down my formulas. The more I write them, the more I remember them. Okay. So just like before, we need an r on that sign. I'm going to multiply both sides by r to get to here. All right. Now I can use this formula for this piece. So that'll give me r squared equal to -2y. And you can replace the r squared with x squared plus y squared. So that'll give me x squared plus y squared equal to -2y. So we have finished the conversion from polar to rectangular. So that's half the question, right? Then it says identify and graph it. So in order to do so, convert this to a, put this in circle standard form. So we said get all the x's and y's together in order to do so. So I'm going to move that over. So I move the 2y to the left by addition. So now it's equal to 0. So these are the ones that we need to work with. The x squared is already done. So we only have to complete the square once. Okay. So what is the special number that needs to be added? Right, so look at this, all the y terms here. Half of the b is going to be 1, right?
1.
Square it. Still 1, right? Now this will factor perfectly because it is a perfect square. The square has been completed. Then it will become y plus 1. Does it make a little more sense? All right, so what's the center?
0, -1.
Yeah, 0, -1. Radius?
Square root of 1 or 1.
Right. So if we were to graph this guy, zero, -1 is right here. I go out 1 in every direction. So my circle looks like this. So the identify part is just saying, yeah, this is a circle centered at 0, -1. And there's my graph. Guys have any questions on the first 3 examples? All right, guys. Well, we'll stop here. And Thursday we'll finish 10-2, 10-3, and maybe 10-4. We'll see.
And you're going to remove those